Thank you everybody for joining this webinar. Let's go ahead and get started. My name is Vikram and I work for GL Communications, and I'm joined on this webinar by my colleagues Alan Revzin and Sunil. And today we are going to talk about our TCP Networks Analytics software program. So thank you for joining us. So we are GL Communications. I think a lot of you are already familiar with us, but in case you're not, we are located in Gaithersburg, Maryland, United States. And we also have a development office in Bangalore, India. And actually, Sunil and Sanjeev are joining us from our Bangalore, India office. So thank you to both of them for staying up late to be with us on this webinar. So we've been around for more than 30 years. We are a telecommunications consulting company. We also manufacture test and measurement equipment, both hardware and software. And I'm not joking when I say all telecom networks, we have some sort of test equipment for basically any telecom network that you can think of. So whether it's your legacy public switch telephone network, whether it's voice over IP and Ethernet, whether these are wireless networks, 2G, 3G, 4G, 5G, whether they're fiber optic networks like SONET and SDH, no matter what land mobile radio, we basically, for all different types of telecom networks, we have test equipment which can analyze these networks, interface to them, and measure their performance, monitor the traffic, visualize all the traffic, capture, store, and do all sorts of analysis on the calls and the data that's traversing these networks. We sell our solutions all over the world. We have sales representatives basically all over the world. And then, of course, we also do business directly here in the United States. So let's just dive into the subject of today's webinar. You may know that we have a lot of different solutions. One particular solution of interest to customers that we haven't really emphasized in the past is our TCP solutions. So first off, just a quick recap. What is transmission control protocol? Why is it so important? So transmission control protocol is basically one out of two dominant layer 4 protocols, and it uses IP as the network layer, and it is used to ensure reliable transmission of data. So whether you're transmitting files or whatever it may be, email, web traffic, watching a pre-recorded video, whatever it may be, a remote desktop connection, SSH, all sorts of different applications all rely on TCP for reliable data transfer. So why is it such a used algorithm? Why is TCP so popular? Is because it has built-in algorithms that can control the packet sizes and detect congestion and detect if there's any packet loss and resend packets if it detects packet loss. It's just a very reliable protocol for making sure that the data gets from point A to point B without corruption and without loss. So that's why it's used for all these different applications that I've mentioned before. Now, keep in mind that there are some applications that do not use TCP, and that includes like streaming services. So UDP, User Datagram Protocol, is used for streaming services such as voice over IP, video streaming, and so forth. So why is that? It's because UDP is not actually concerned about congestion. It's not actually concerned about packet loss. It doesn't care. It's just going to blast packets out from point A to point B, and if a packet gets lost, so be it. it doesn't really matter. If you're in a real-time conversation, you don't really care if one or two packets gets lost. You're not gonna you don't want the application to have to waste time and go through the trouble of resending packets. One or two packets lost doesn't affect the audio quality all that much. And because you're in real-time communication, you want to stay real-time. So UDP is used for streaming services, but TCP is what's used for data transmission. You see you can take a look here at the actual protocol header. It's like I said, it's usually writing IP, and furthermore, that IP packet is usually encapsulated in an Ethernet frame. So that's TCP. I think a lot of you are already familiar with it, and so now what I want to talk about next is, okay, that's TCP. You're probably listening on this webinar because you're interested in capturing TCP traffic and analyzing TCP traffic because, like I mentioned, it's basically ubiquitous. So now the next question is, how do we capture TCP traffic? And more generically, how do we capture Ethernet traffic? So many of you may be familiar with our PacketScan HD hardware platform. We won't delve into it too much on this webinar, but if you have questions, feel free to ask us. Basically, PacketScan HD is a server-grade PC, and if you can see my mouse here, it has a specialized network interface card for capturing high-speed Ethernet traffic. So when I say high speed, I mean all the way up to 100 gigabits per second. We have different versions. We can customize the network interface card. We can go from 1 gig, 10 gig, 40 gig, 100 gig. So we have very, very high speed capturing capabilities without loss. It's a wire speed application, and the PacketScan HD is also customizable in terms of its RAM and storage capabilities. You can imagine that if you're capturing at high speeds, like at 100 gigabits per second, you're going to fill up your RAM very, very fast. So we can customize the storage capability on the PacketScan HD. This is a full-blown Windows server-grade PC. And most importantly, it comes with our PacketScan software. So the PacketScan software, if you've seen our previous webinars, it is a very powerful protocol analysis software. We like to think of it as Wireshark on steroids because that's what it is. It can do protocol analysis at a much deeper level than Wireshark. It includes hardware filtering capabilities so that you can just focus on the traffic you want to capture and filter out everything else. You can generate alerts, so when certain types of traffic is detected, you can send an alert that either pops up on the screen, or you can configure it to send an automatic email, or you can configure it to automatically save a packet if a certain packet is detected. It's got a lot of powerful capability that you can do, all from the comfort of a nice, easy to use graphical user interface. So PacketScan HD is what we promote for high speed Ethernet capturing, and it can also notice that on this screenshot we can put this in either a rack mountable PC or a portable PC. The portable lunchbox PC it still has plenty of horsepower in terms of RAM and processor speed and SSD storage and so on, and yet it's light enough to be carried just like a briefcase, basically. So you can take this into the field and do your capturing there. So this is how we capture Ethernet traffic, IP traffic, and therefore TCP traffic. And finally, we can capture on copper interfaces or optical interfaces. If you're capturing over fiber optic networks, we can capture over those networks. Single mode, multi-mode. We're compatible with basically all the SFPs on the market. Very, very flexible appliance, and so that's why it's one of our best-selling products. Actually, is PacketScan HD. You would want to plug this into a monitor port on a switch, or use a network tap in order to capture all of the raw traffic. Okay, so just a little bit more about the PacketScan protocol analyzer software. It's similar to Wireshark in terms of its layout, and you can see all. And actually, here what we've done is, instead of showing you the raw packets, we're showing you actual calls, VoIP calls that have been collected in real time, and PacketScan can intelligently group all the packets into the aggregate calls and then display all the calls here. So the source IP address, the destination IP address of the call, what UDP ports it was residing over. You can get all of the statistics on the call. You can get the call detail record, and you can basically do a lot with all of this. You can really break down the call. You can determine voice quality. You can save the call, play back the call. You can determine the total number of packets that were lost, mean opinion score, all sorts of different things you can do. So and the views are all customizable. We also provide lots of graphs that you can see as well. This is just one screenshot which shows you how to use the PacketScan software. So again, this PacketScan software is essential to what we're going to talk about next, which is our specific TCP Analytics program. The TCP Analytics program will work directly with PacketScan and take it a step further to do TCP Analytics. So here we're showing you a UDP traffic, because we're looking at a VoIP call and showcasing the types of things we can do with the VoIP call. But our TCP Analytics can take it a step further and do TCP analysis. Okay, so just a little bit more about TCP and what you can do with our TCP Analytics application. Like I mentioned, TCP can be used for all sorts of different things, for email, for web traffic. Those are probably two of the biggest uses of TCP. And basically what you have in any TCP connection is you usually have a client and a server. So that could be an email client and an email server. It could be a web client, just like your normal web browser, like Internet Explorer, Google Chrome, Firefox, and so on. It could be that web client talking to a web server elsewhere in the world. So you have a client and a server pair, and you have TCP data flowing back and forth between the two. The TCP Analytics application will be able to analyze the TCP connections between your internal LAN computers and the outside servers and other computers on the wide area network. So you can think of it as, you've got a big, massive enterprise, and it's connecting to servers around the world, and you want to be able to see all that data, all that traffic, and dissect it and see, who's talking to who and how much traffic is going back and forth. And vice versa, from the server perspective, if you're hosting a server, you're going to want to deploy this TCP network analytics application so that you can see all of the different clients that your server is talking to. It could be talking to several thousand different clients simultaneously. So you would want to see all those connections in real time, see what's the status of all those connections, how much data is flowing back and forth, how much load and congestion there is there packet loss, are the TCP connections failing? It's a great application that you can put in to basically help you diagnose all aspects of your TCP connections. So yeah, another a very important feature of our application is that it'll identify network attacks, and we'll show some screenshots about that. But basically, a lot of denial of service attacks are based on flooding a server. So you can imagine if malware gets onto thousands of client PCs and basically instructs those client PCs to hit a server simultaneously, it can bring down the server simply by sending SYN packets, SYN TCP packets. It can consume all the resources of that web server and therefore crash it. So this TCP network analytics, if it's running, it'll be able to easily identify, okay, something is wrong here. We're getting a massive number of TCP connections. They're not full connections. They haven't, they're consuming resources, and they're not actual TCP full connections. So you can identify denial of service attacks in real time and be able to act quickly when they're happening. You can also just troubleshoot server issues. Is your server operational? What is the connectivity, and what is its performance? So all of that is possible with the TCP Analytics application. Okay, so at this point, I'll stop talking and hand it over to Sunil. And Sunil will walk you through some of our screenshots here to tell you more about the TCP Analytics application. So Sunil, feel free to take over.
Yeah, thank you, Vikram. As Vikram explained, our TCP Analytics can be used in our PacketScan application or in PacketScan HD application. So here we are showing how the TCP data is collecting from the captured PacketScan application. And as you can see, it was processed around 20 million packets. So this is just a simple example. Our TCP Analytics is capable of processing up to billions of packets, and which we had verified using our high definition packet scan application. So basically, the first thing is collecting all the TCP data for the further processing. So once we collect all the data, the first thing is the main dashboard window, our TCP Analytics dashboard window, where user can quickly view like all the connections, all the information, like what is the total TCP connections, and what are all the errors, either whether any successful connection or any open connection or orphan connections, or is there any particular server which is rejecting the client request. So basically, dashboard shows complete information about collected data, and we do support both IPv4 as well as IPv6 packet analysis. So in this case, if you can see that we are providing detailed information about total number of TCP connections. So if you observe that in the first window, you can see that it has collected almost up to 200 GB of data, and it has processed without any lag or something. So it has processed up to 200 GB of data, and it has provided complete and detailed information about TCP connections. And in the dashboard, so user can easily click on our main menu option so that they can sort out and check on quickly. They can verify interested IP address, or if they say, suppose if they want to see like number of a packet loss, if we can say why the connection is rejecting, so they can easily sorting out the column, so that quickly they can identify which particular IP address is causing the problem. So in from the next slide, we will go through with the detailed information about each and every statistics. The first thing is total TCP connection information. Like I said, it will give quick information about like how much data we had processed. That is the total number of bytes we had processed, and out of that, how many TCP packets we had, and number of TCP connections, and how much out of those connection, how many connections are due to sequence errors. If there is any mismatch between the sequence number, so we are listing out how many sequence error it has happened, and how many reset connections. Similarly, how many congestion we had, and whether had any severely congested packets, and how many server IPs we had processed, and finally how many client IPs we had processed. So basically, this will be very, like I said, our HD application is capable of like capturing up to dozens of even terabytes in size. Even if it is like in the terabytes of size, we are still able to process that much of data. And this will be useful like while analyzing some external interface in the interface scale. And also suppose uh, if you have to see the status of some of the entire network, because when we are consider talking about interface, the network will be very huge, and traffic can be in terms of Gbps, or even it may reach up to terabytes also. Once we start capturing, once we start monitoring the network, even the recorded data can reach up to terabytes, but we are still able to process terabytes of data. So next thing is the TCP connection statistics. So first thing is the overview, like how many connections we had, and how many sequence error, and how many reset packets we had. Next, we are digging to deeper, like how many connection statistics. So first one is connection distribution in percentage. So when we talk about TCP analysis, so there can be three main important parameters, like whether the TCP connection is open, or whether is TCP connection is successful, or if there is any ARP1 connections. Say it is like Vikram said, there can be possibilities where SYN messages are continuously capturing, so that can cause a problem in our network. So we can identify like how many such percentage of data we had. So in this case, we had like a closed connection bytes out of 73%, and there can be open connections, and similarly closed connections. And similar to that, now one more statistics we are providing is like top servers rejecting client connections. So there can be chances that whenever a client requesting for a connection, the server can either accept it or it can reject it. If it is continuously rejecting, we can identify what is the particular IP address which is keep on rejecting the client request. Like from the IP address, port number, and percentage of reset. Like whether it is due to reset or sequence error, or whether it is due to which particular port IP and port number is rejecting the client connection. So we can easily sorting out, or we can identify what is the root cause of that particular problem that rejecting the client connections. So in this way, we can analyze server behavior and identify the threats. Like I said, if we um, if your server keep on rejecting the clients, easily identify the particular IP address and port number, respective port number, which is rejecting the connections. Like I said, we also display all the closed connection, open connection, and orphan connections, and how many total number of connections we had to the particular server and server address, and with respect to port pair connections, respective port numbers. So next thing about server congestion statistics. So these statistics will be useful when identifying like server traffic and congestion, as well as application traffic and congestion. So if we consider our first image, that is soft server by bytes transferred, and you can see that particular one of the IP address with respect to port number, it has almost transferred 19 GB of data. So similar way, we can identify what is the data from the different IP address it has been transferred. If you consider second example, that particular IP is almost transferred 18 GB of data and 17 GB of data, and so on. So likewise, we can identify top server, which is top server which transferred the huge number of data. And if I consider one more window, that is our top server with reduced window size, that is congested. Uh, like I said, server traffic congestion. If there is any congestion in the server, so which we can identify which IP address and which port number is causing a huge number of traffic congestion. So not only with respect to like how the data, how much data has been transferred, or how the traffic has been congested, we are also providing statistics about packet loss. Some of the top server which causing packet loss, and some of the top TCP application which is using internet traffic. So first one is, so these statistics will be useful when identifying a pure network or TCP connection performance. Suppose if you have like a huge network, and if you are facing any pure network, we can identify what is the root cause of that particular problem by identifying the particular IP address and port number and the root cause. Like in this case, the first one is like identify packet loss and the retransmission. If we have any packet loss during the transmission, or if there is any retransmission because of unavailability of acknowledgement message, then we can say, okay, this is the one particular IP address and port number that is causing so many like a percentage of sequence number, that means packet loss. It is causing the packet loss, so that we can identify the particular network in order to rectify it. And it also indicates the most affected servers by percentage of TCP segments with sequence number errors. And that can be due to because of missed packets, or packets retransmission, or reordering the packets. So one more statistics we are displaying, the like I said, top TCP applications by received bytes. So one such example, generally web data, browsing data. Whenever we start doing browsing, there can be chances that we can either download the huge data or something. So in a similar way, we are providing the statistics so that which particular port number is utilizing more number of bytes. So this way we can identify high consumption application for network capacity planning. So we can plan accordingly. In this case, we can, if we ignore the port TCP port number 80, generally used for browsing. So that is almost downloaded around 7 GB of data. So in a similar way, we can identify which particular port number is consuming traffic. So far what we shown is the our TCP Analytics Dashboard, the statistics that will give us a quick information about the overall connections and packet loss information and data transferred information. So our last two statistics are like top client IP address, that is the by bytes, and client TCP connection, as well as another one is top clients by packets. So these are all same statistics. So one is represented in the form of bytes and another one is represented in the packets. So this is the some of the top client IP address which has been requested data, like how much data it has been received or transferred. And so one such example, if you see here, it is almost 132 bytes, 132 GB of total bytes it has been transferred. So in this way, not only server IP address, so by knowing the respective client IP address, so we can identify data theft from the company network. So if there is any huge traffic flowing to particular client IP address, so we can quickly identify by knowing that what is that particular IP address which has been receiving or transmitting huge data. And not similar way, it will helpful in recognizing large uploads and downloads of the affected machines. So apart from that, if it is any malware in the network, or if there is a viruses which is flooding the network by sending requesting for the client connection, so we can easily identify what is that particular IP address which is causing those, whether it is a potential virus or it can be whether it is a malware or it is causing any whether it is actual machine from the network or whether it is a viruses or malware. So we can identify using our this some of the client IP address which is taking so many bytes of data or in the form of total packets. So like I said, not only IPv4 address, we are also supporting TCP analysis for the IPv6 address as well. So all the statistics and all the packet loss information and all the top server which is utilizing huge data. So all those statistics are available for IPv6 address as well. Vikram, you want to add anything from here?
Sunil.
Yes. Now we go to more details in depth into TCP connections. Before all the screens were basically snapshot of summary, very top level view, maximum talkers, and so on. The following screens will show details about all TCP connections we're analyzing. And as we discussed, we can analyze billions and billions of connections and look into each TCP connection in details by linking selected line to main screen of PacketScan, which displays only packets that belong to particular connection. If we select line in any of connection screens and click on connection packets, it will display only packets for this particular connection. And there are three types of connections as we discussed: closed connections, open connections, and orphan connections. And classification is based upon if all major messages are present, seen message, intermediate messages, and fin or reset message, connection is classified as closed connection. Open connection, basically it is connection in progress which has seen messages and intermediate messages. And orphan connections are connections which don't have any SYN messages at all. So TCP closed connections have all the packets for each message, and after information is collected initially, we can open screen very quickly with one of types of connection, in this case closed connections, and we can quickly scroll or sort by column and select any connection, click on connection packets. In this case, we go to PacketScan and see all the packets in details. What is important here is when you sort, why we emphasize sorting, because it could be very many lines here, millions or even billions of lines. And if we want to look on particular server port which identifies TCP IP application like port 21, it is FTP, we can see all connections which use FTP protocol on higher level. We can see client address and port who is connected to server, and we can see how many packets, how many bytes. What is important, if we want to see some connections have very dirty data, invalid sequence numbers, which tell us that there are a lot of retransmissions, we can sort by invalid sequence number or by congestion count. Congestion count is actually window size, which is reduced to less than 256. Keep in mind that window size and TCP packets are scalable depending on connection speed. It can be scaling factor, but usually if connection count is significant, it means that connection is problematic and a lot of retransmission, very inefficient. Severe congestion is when window size is reduced to 0. It's usually very rare case, almost stops to a halt and very often never recovers by any reason. It's like network connectivity lost and other things. Flags shows reset flags if server or client resets the connection. Okay, if there are no problems, and sequence errors if there were sequence errors, retransmissions in the connection. Open connection basically is connections in progress, which are open and ongoing, but there is no fin, no closing connection yet or reset. It's the same columns. We can sort, we can look what's going on. We can see top talkers, congestion problems, retransmission problems, and so on. And at the bottom, what you see is push buttons which allow to export any tables to CSV file. We will see it later on. Or if you are interested in what kind of application is it, you can select line, click on port description, and it will tell you what TCP application is for server port 13. Orphan connection. Orphan connections usually don't have any scenes, and the indication of two things. Either we started to capture too late, or it's denial of service attack. Probably it is subset of orphan connection, but by definition is connections which do not have proper SYN messages at the beginning of the trace. TCP server connection summary. This is very useful summarization of all connections. They display information by server address and port, basically address of computer and TCP application, because on many servers people run different kind of applications. It could be different database server and other types of servers. So it is important to know what server port per TCP application. Once again, we can look at number of packets, bytes, especially for servers. It is interesting to see error sequence numbers. It means that a lot of retransmission happening, and it could be by several reasons. It could be that problem with network. It could be server is too slow and client tries to get more data and so on. So by sorting by these numbers, we can analyze what servers have particular problems. This is subset of orphan connections by servers, and here scene count is 0. It means that most likely we don't have really any denial of service attacks, because it counts number of scenes in orphan connections, but not two scenes, because usually connections start with client sending scene and server sending back scene and ACK, and if we have only single scene at the beginning going to the same server and we have huge count, it means that somebody is bombarding server particular service port, let's say 80, right? Web server with scene packets immediately disconnecting, resetting connection and trying to connect again. It will be indication if we see like many thousands or even millions of scene count. It means it's denial of service attack. Let's go. This is very interesting summary by client. So what is particular to this one? The key here is client address but server port, because if we have, let's say, FTP client and it opens very many connections to the same server port, each time client port will be modified, but what essential is what server port the client accesses. And in this case, let's say line 2, we can see that client is accessing server port 21, and we can see here is nothing to pay attention to, is limited number, but if we see millions of packets, it could be that client is trying to flood server with packets. It could be also indication of denial of service attack or whatever, but we can see what clients access what kind of server excessively, and we can see what clients have sequence errors or congestions or severe congestions or resets. If server by some reason rejects, because you can set up server accepting certain subset of clients, let's say by IP addresses, then huge server will reset connection each time, and if you see huge reset count, it means that something is interesting going on here, and network administrators probably need to pay attention to this. Well, this is denial of service by clients. It will be interesting to watch, as you can see here, if client is using really excessive, and we will have scene count 0 or 1 means nothing, but if you see thousands, it is really a denial of service. So as I mentioned before, from each table we can export to CSV, and this CSV file we can later on import in database or have this snapshots like by day or by month and so on, and analyze in time what's happening. So we export this information, can be just open in Excel, imported in database, or used for presentations and so on.
Okay, thank you, Alan. Thank you, Sunil, for walking us through the main TCP Analytics software program. And thank you all for attending this webinar